Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to be doing a restoration on a 1922 Chelsea Model 101 regenerative receiver. Now I've been wanting this receiver for quite some time, and I was lucky and was able to pick this one up at auction about a year and a half ago. So it's been sitting there waiting restoration, and now I'm ready to get started. But before we do that, let's talk a little bit about how this radio came about. Now, as you all know, Edwin Armstrong patented the regenerative receiver back in 1914. Well, unfortunately, him and Lee DeForest got into it legally over that patent, and he spent many years fighting the patent rights to that thing. And in the process, he was really losing a lot of money. So his lawyers came up with the idea of licensing out that patent to small radio manufacturers to try and recoup some of that money, since none of the big radio manufacturers would come on board. So in that process, what happened was 20 radio companies wound up purchasing that patent right, and of those 20 companies, Chelsea Radio was one of them. And part of the deal was 5% royalty on every set sold would go to Mr. Armstrong. So it turned out quite lucrative for him, but it opened the door to a lot of radio companies that otherwise wouldn't be able to produce radios. So the Chelsea Radio Company was actually a radio parts manufacturer who got their start back in July of 1920. Now, they were known for their high-quality parts, and they did all their own Bakelite manufacturing in their facility. They were also well known for their condensers, which were used in the loose coupler type radios back in the early 20s, and they were quite attractive, to be honest. So the 1922 Chelsea Model 101 was Chelsea Radio's first radio offering after that agreement with Armstrong. And as you can see here from the schematic, it aligns pretty much with the patent itself. There are just a few minor variations between the figure 2 of the patent and the Chelsea Model 101. Now, in addition to the Model 101, they also produced an amplifier, a Chelsea Model 111, which I've actually never seen in real life. I've only seen a couple of advertisements for it, no pictures whatsoever, and I don't know anyone that owns one. I would love to see one at some point. Now, the regenerative receiver itself has a range of 150 to 800 meters, which in frequency range, we're talking 400 kHz to about 2 meg. This particular model was, it's relatively small. It was 10 inches by 9 inches by 6 inches. And it sold for about $40. In this particular ad, it's $45. So it was relatively inexpensive. Now, my particular radio here has some issues. As you can see, the face definitely has a lot of discoloration, a lot of grime, some damage. The dials themselves, the paint's missing on some of the indicator lines, and along with the lettering, numbering. The case itself is kind of rough. It does have some damage that isn't visible here. It was also refinished in lacquer, which is not the correct finish for this particular radio. And internally, the biggest issue is that varial coupler. As you can see, there is quite a mess there with the unraveled wire on the ball coil. And in addition to that, the rheostat is actually open, so the nichrome wire needs to be replaced in it. But other than that, it's pretty intact and everything is definitely fixable. So the first step in this process is going to be disassembly, and let's go ahead and see where it takes us. Now this condition-wise, this thing's got some issues. As you can see, the coil here is definitely shot. Everything's there and seems to be in order. There is some definite issues with the faceplate here that need to be cleaned up. The case itself is in relatively good shape. There is a crack here and here where the hinges go in, so I'm going to have to address that. That's going to be a little tougher than usual, but I'm going to try the best I can to keep as much of that original finish as possible. So let's go ahead and get started on at least separating the faceplate from the case. So I'm going to probably go ahead and remove all the components that I can, just so I can clean up that faceplate and get everything cleaned up there. The case itself has got some issues, obviously. I didn't notice this, but yeah, we're going to have to do some repairs there. So yeah, I do have a little bit of work to do on the case. So I'm going to go ahead and start disassembly.
Okay, so to get that coil off, I'm going to have to desolder those 4 lines there. There we go. Alright, so I'll leave those 2 pins in there. And the thing that you'll find interesting about Chelsea Radio is that it is actually one of the few companies that only use Bakelite on their panels. And the reason behind that was they were actually a molder of Bakelite. So they had all the equipment to produce their own panels and components. So they did. Okay, so I've got a couple things going on here that I'm concerned with. There seems to be all this bubbling up here. And what I'm wondering is if somebody didn't spray lacquer on here. And that's what that is. It's just a haze of lacquer. I'm going to try a little bit of lacquer thinner. See what we can do there. Doesn't appear to be varnish either. It could actually be the surface of the Bakelite. Okay, I'm going to try a couple of different things here until I can figure it out. So from what I've been able to gather here, I seem to have some delamination happening. And it's just on the surface, so what I'm going to do, and it's kind of a little real minor here, but definitely major here. What I'm going to do is I'm going to wet sand the whole surface here and try to smooth all that out and then polish it. So let's see how that works. I think, yeah, it's pretty trashed otherwise, so I don't want to leave it like this. So let me see what I can do here. Using a 600 grit sandpaper. Okay. Go ahead and rinse this off. Alright, now I'll go ahead and hit this with some rubbing compound, see if we can't get some shine back to it. Okay, so it's not perfect, but it does look a lot better. Got rid of a lot of that delamination. I didn't expect it to be perfect or extremely shiny, but don't want it to be. I want it to still resemble the antique that it is. I mean, this thing's 100 years old, so. Okay, so this is a little bit of a puzzle, but I really got to get this out of here. And there appears to be, and I don't know if I can show that, there's a pin like that up here next to the ball. So I got to somehow try and get that out of there. Don't know if it's even possible. Ah, it is. Okay. Got it. All right. Okay. These are screwed in with screws. All right. The screws are there, soldered to both ends of this. Now, there are a couple of different adhesives that they use. They really didn't use a glue, so to speak. What they used was shellac to hold this in, or varnish or lacquer. But more than likely, Chelsea used a lot of shellac. So I'm going to assume that's probably what's the case here. So yeah, this is definitely shellac. Oh yeah, that wipes right off. Yeah, if it was anything other than shellac, alcohol would have no effect on it. Alright, so the first thing I want to do is I want to go ahead and remove this screw from this wire so that I can unwind the wire. There. This is what they call RTV sealant or silicone. So let's go ahead and get started. The first thing I wanted to do is tape off the areas that I don't want the sealant on, basically. Mainly because it's messy. The thing I really like about this is it gives you time to work, which varnish doesn't really do that. Or shellac. You can see this is not fun. Well, since this is getting a little hard to handle, I'm taking a little bit of electrical tape here And I'm going to go ahead and secure this for now. And then come back to it after this part dries. Alright, that'll work for now. Let that dry and I'll go on and finish it up. Okay, this thing turned out pretty decent. I mean, I had to use the RTV because this is a 18 gauge wire. It's very stiff, very hard to work with, and to secure that to this form I really needed something with some strength, so that's why I went that route instead of shellac. If I had all the proper factory equipment to do this, yeah, I could have done it in shellac, but anyway. What I'm going to do is I need to get this thing ready to go. I got the pin in here. Go ahead and go from the side. All right. Okay, so all the parts are all cleaned up. I've got a little bit of work to do on the dials. I'm going to need to polish them up and get the lettering back on them. Okay, so let's begin assembling the front panel here. A little bit of thunder. Alright, so that concludes the assembly of the radio itself. Now I just need to finish up the cabinet. Alright, so the only repairs that I really need to make to this box, other than refinishing it, is right here and right here. Obviously the wood has split, so that's an easy one. Simply going to use some wood filler. This is a red mahogany color. Now, the reason I'm leaving these screws in here is obviously to keep me from having to re-drill this. Okay, so now I need to go ahead and repair these cracks. I'll leave that. That's a dent, but it's part of the history of this radio. And really, this is relatively easy. Just go ahead and get this glue in here. All right. Okay. All right. So I'll go ahead and let that dry overnight. So I've let these things sit overnight. I'll go ahead and see if I can't sand these down this morning. Alright, so I'm ready. So I went ahead and fired this thing up as a pre-test, and much to my despair, what I've discovered is this rheostat is bad. And while it looks intact, it's actually broken in several places along this this coil form. So I'm going to have to rebuild this rheostat. Unfortunately, these rheostats here are Chelsea specific and they're extremely hard to find. So I don't have any spares, so I'm going to have to repair this one, which I can do. I need actually the 22 gauge, but this is 26 gauge, a little higher resistance, so that's not going to hurt anything to have that. So I'm going to go ahead and use what I have on hand to rewind it. That'll allow me to put a little more space between the coils in order to get the same amount of resistance. So okay. Yeah, there you can see the broken parts right there. Broken. Many broken spots. Alright. Keep it taut. Okay, so this is the end that will not be using excess on. Okay. Now, 18 ohms. Plus an ohm. About 9 ohms at center. About 5 ohms at a quarter. Alright.
Okay, so I've gone ahead and I've reinstalled the variable resistor back into the radio itself, so we've already taken care of that. And I'm ready to go ahead and get that thing working. But before I do that, let's talk a little bit about how this particular radio operates. So what we have is a typical regenerative receiver. You have an antenna, which is picking up all these modulation envelopes. You have a capacitor and this tap coil here, which are going to help narrow down all those envelopes to one particular envelope or one frequency. Once it does that, it's passed through this grid capacitor to the grid of this tube. Now, the way a vacuum tube operates is very simple. You have a filament voltage here and a plate voltage here. Now, the filament voltage is a lower voltage than the plate voltage, so current is going to flow through the tube and through that grid from the filament to the plate. And as it does that, this signal that's coming in is going to cause that voltage to vary. And one of the things about a tube is it only conducts one direction. So an envelope goes positive and negative at the same time. So what's happening is half of that envelope is not being conducted because there's only a positive flow in this tube. And as such, the top half of that envelope is going to carry an audio frequency on top of it. So what is happening is your RF is being varied at an audio rate. And as such, that RF is passing through this coil here, and this coil is inducing that signal back into this circuit here and back through this grid circuit. So what's happening is it's regenerating that signal. It's making it bigger and stronger and clearer. So that is the basics of a regenerative receiver. Now, what's unique about this particular receiver is that signal is being developed across this tube. Now, of course, you have your RF capacitor here, which is going to take that RF signal that's attached to that audio writing the RF signal, and it's going to go ahead and shunt that to ground. And when it does that, it leaves pretty much just the audio component left over. So that's what you're hearing here at the headphones. Now, what Chelsea's doing here and what the Armstrong patent did in figure 2 is it's taking that signal from the filament circuit, not the plate circuit. Most regenerative receivers do it at the plate circuit, and I think the main reason is because of efficiency. The plate circuit is a higher voltage. It's also uses a B battery, which lasts a lot longer than A batteries do. So for efficiency's sake, it makes more sense to use the plate circuit. But in this case, we are using the filament circuit. So that is how this particular receiver operates. Pretty simple. So let's go ahead and see what it looks like in operation. Okay, well, I'm very happy with the results here. This wraps up another successful radio restoration. Now, this is going to be part one of a series I'm starting on the Chelsea radio line. My next video is going to be on the Chelsea Model 102, so keep an eye out for this if this is the type of thing you'd be interested in. So this concludes yet another episode of Antique Radio Archaeology. Happy restorations, everybody. Hope to see you again next video.